This is the third section of chapter 3 on continuous distributions, and this section is on the mean and variance of a continuous distribution. So let's start off with the mean, which is E of x or mu, and basically we take our probability density function PDF, we multiply it by x and integrate it between the values for which the whole probability appears. So for example, if we had a PDF that looked like this, then our limits would be 7 and 12, because this is where the whole probability is between those values. There's no other probabilities anywhere else, they're all 0. And then for the variance, or varx, or sigma squared, we do the PDF times by x squared, then integrate it again between the values that are given in the question, and then we take away the mean squared, E of x squared. So I've written it down here like this. So there's our mean squared that we subtract at the end, which means that this part here is the same as E of x squared. So when we work out, or when we do this part and when we integrate it, it's the same as this part. So think about multiply f of x by x squared, multiply f of x by x. And lastly, just like the rules we have for discrete random variables, we've got similar rules for like coding with the mean and with the variance. So E of ax plus b is equal to a times the mean plus b, and the variance of ax plus b is a squared times by the variance. Example 7. A random variable y has probability density function given by this. So a quarter y for y between 1 and 3, including 1 and 3, and 0 for everything else. The first thing we want to do in part A is to find the mean of y. Now that's going to be an integration between 1 and 3, so that's where all the probabilities occur, between 1 and 3, and then y times by f of y dy. Okay, well we know what f of y is, and that's going to be a quarter y. So basically we have y times by a quarter y dy, which we can write as a quarter y squared. So now we can work that out. So a quarter y squared is going to be a quarter y cubed over 3. So that's going to be 1/12 y cubed between our limits of 1 and 3. So if we work that out, that gives us a value of 13/6. So basically 1/12 times by 3 cubed, 27, minus 1/12 times by 1 cubed, or 1/12. So that gives us 13/6. Part B, the variance of y. So that's going to be between the limits of 1 and 3, y squared times by f of y dy, minus the mean squared. So we're going to subtract 13/6. Let me write it as E of y squared, and then we'll substitute it all in. Right, so 1 and 3 here. So f of y times by y squared is going to be a quarter y cubed. So a quarter y cubed, I could take the quarter over if I wanted to. And then we're going to take away 13/6 squared. So we'll do the integration. So that'll be a quarter y to the power 4 over 4. So it'll be 1/16 y to the power 4 between my limits of 1 and 3, and subtract 13/6 squared. So now we'll work out 1/16 times 3 to the power 4 minus 1/16 times 1 to the power 4. Take away 13/6 all squared. And working that all out on the calculator, we'll get 11/16 for part B. So nice exact answers there. Oh, sorry, 11 over 36. Should learn to read my calculator properly. 11 over 36, and then we can move on to part C. And part C says the mean of 2y minus 3. So that's equal to 2 times by the original mean minus 3. So that is 2 times by the original mean was 13 over 6 minus 3. And that becomes 4 over 3. And then part D of this question, the variance of 2y minus 3. So this is going to be a squared times by the original variance, so 2 squared times by the original variance, which was 11 over 36. So 4 times 11 over 36, and that becomes 11 over 9. Example 8, a random variable x has probability density function, this function here, so between -1 and 3 and 0 for everything else. And in part A, we want to sketch that probability density function. So we're going to need an x and a y axis. So on our y axis, that will be f of x, and on our x-axis here, you'll notice that we're going from -1 to 3. So let's maybe put -1 here and 3 here. So from this, because there's a negative there, we know it's going to be an n-shaped quadratic. It would be useful to know if there's a maximum between these two and where that maximum will be, and that might be helpful. So there's different ways of doing it. I'm going to find the maximum by doing differentiation. So if I say let y equal -3 over 32, so I'm going to take the negative out and then write this as x squared minus 2x minus 3. Now it doesn't matter, I could leave the negative in there. So now dy dx is going to be -3 over 32, and then I'm going to have 2x minus 2. So there's going to be a maximum or minimum or a turning point when dy dx equals 0. So that's when -3 over 32 times by 2x minus 2 equals 0. We can divide both sides by -3 over 32. So then that just leaves 2x minus 2 equals 0, which means that 2x equals 2, which means x equals 1. So there's a turning point at x equals 1, which is going to be here. And it'd be useful to know what the y value is at that turning point, or the f of x value. So I now just substitute this one back into here and see what I get. So I'll get -3 over 32 times by 1 squared minus 2 times 1 minus 3. And that gives a value of 3 over 8. Now, there are other ways of finding a maximum. You could complete the square if you wanted to. That's a different way of doing it. I've just decided to do it that way. So I've got a maximum. Let's put the maximum here at a value of 3 over 8. So that allows me now to sketch this quadratic, or this probability density function, like this. And that's what it should look like. So we should really include points where maybe it crosses the axis or the maximum. So we can work out this point here where it crosses the y-axis by making x equal to 0. So we'll do that. Y-intercept is going to be when x equals 0, and if x equals 0, we've got -3 over 32 times by 0 squared minus 2 times 0 minus 3. and that gives us 9 over 32. So this point here, where it crosses the axis, is 9 over 32. Right, so part B, we want to find e of x. Now, normally what we do is we'd take this, we'd multiply it by x, and to use integration between the limits of -1 and 3 to find the mean. But if you have a look at this graph, it's symmetrical about this line here. Okay, that's a line of symmetry. Line of symmetry. And wherever the graph of f of x has a line of symmetry, that's where the mean is. That will save time. So we can say e of x equals 1, and we can just write by symmetry. Now the same rules apply when you've got a discrete random variable and you've got a table. If there's symmetry in the table, you can say the mean is a particular value by symmetry. So the same applies here with this continuous random variable or this continuous distribution. So if there is a line of symmetry, let's write that down. If there is a line of symmetry in the graph of the PDF, we can state the mean, e of x, equals the x value of the line of symmetry, and we just write by symmetry. That's how we found it. Okay, so if that applies, that can save you some time. Saves you having to do integration and work all of that out. You'll get exactly the same answer, 1. Example 9. The random variable x has a probability density function, this, and we want to find e of x and var of x. Now you'll notice that there are different functions rules depending on the value of x. There's one rule here for x between 0 and 3, which is 2 over 15x, and then for x between 3 and 5, we've got 1/5 5 minus x. Now when we get something like this, it's called a piecewise function. Now if we want to find e of x, the mean of a piecewise function, we need to find e of x of this first part and add it to e of x of this second part. So I've made up my own notation here. So the mean between 0 and 5, from there to there, is the mean between 0 and 3, and we add that to the mean between 3 and 5. And finally, if we want to find the variance between 0 and 5, we need to find e of x squared between 0 and 3, add it to e of x squared between 3 and 5. We add those together, then we take away the mean squared from that. Okay, so let's now work through the question. So e of x is going to equal between 0 and 3. So we're finding e of x between 0 and 3. So that means that we do 12x here, this part of the function between 0 and 3, and times that by x. So that becomes 2 over 15 x squared. And we're going to add to that the function between 3 and 5, which is going to be this times by x. So we'll write that as 1/5 x 5 minus x dx. So I'm just going to multiply out the brackets for the second part before I integrate. So the first bit doesn't change. And then the second part, let's just expand the brackets so that we have 1/5 x times by 5, which is just x. And then we subtract 1/5 x squared. Right, so we're now ready to integrate. So the first term, this will become x cubed over 3. So that'll become 2 over 45x cubed. So 2 over 45x cubed, and the limits are 0 and 3. And then we're going to add to that this integrated. So x will become half x squared when we integrate it, and then this 1/5 x squared will become 1/5 x cubed over 3, so minus 1/15 x cubed, so minus 1/15 x cubed, and that's between 3 and 5. So now we're just ready to substitute. So first set of brackets, we will have 2 over 45 times by 3 cubed, then minus 0 when we substitute 0 in, plus, then for the second set of brackets, we'll have half times by, I need another bracket there, 5 squared minus 1/15 times 5 cubed, minus a half times 3 squared minus 1/15 times by 3 cubed. Okay, so let's use our calculator then to work out what that gives us. So we get nicely 8 over 3 there. So there's our mean E of x. Right, now for part B, we need to work out the variance of x. So remember, what we're going to do is we're going to work out E of x squared between 0 and 3 plus E of x squared between 3 and 5. Once we've added those, then we take away the mean squared. So you don't take away the mean squared of this and this. We only need to do it once. E of x squared plus E of x squared minus the mean squared. Okay, so we'll start with the function between 0 and 3. And E of x squared is going to be this times by x squared. So that'll be 2 over 15 x cubed. Then we're going to add to that between 3 and 5. We'll take this function and we'll multiply that by x squared as well. So we'll have 1/5 x squared 5 minus x. And then we're going to put that in big brackets. And then once we've added those two together first, let's put some brackets there. Then we'll subtract the mean squared. So we'll subtract 8 over 3 squared. So now we'll integrate. So what we'll have is this will become x to the power 4 over 4. So if we times that by 4, it becomes 2 over 60. So 2 over 60 or 1 over 30, x to the power 4. And that's going to be between 0 and 3. And then we'll have this integrated. So when we expand the brackets, we'll basically have x squared, which will become 1/3 x cubed. And then when we multiply these terms, we'll have minus 1/5 x cubed, minus 1/5 x cubed. So then we'll add 1 to the power, so it'll become power 4. And then divide that by 4, so it'll be 1 over 20 minus 1 over 20 x to the power 4, and that's between 3 and 5. And then we'll subtract the mean squared, which is going to be 64 over 9. Right, last line of working now, we'll substitute the values in. So we'll have 2 over 60 here, which is like 1 over 30. So we'll have 1 over 30 times by 3 to the power 4. Then we'll be taking away 0. Just put this in brackets here. Then we'll add, and then we'll substitute 5 and 3 into this. So we'll have 1/3 times by 5 cubed minus 1 over 20 times by 5 to the power 4, and then we're going to subtract 1/3, now 3 cubed minus 1 over 20 times by 3 to the power 4. Just change this 4 here next to the 5, doesn't look much like a 4, so 4 there, and then subtract our 64 over 9. So we'll do that on our calculator and see what we get. Okay, so our calculator, my calculator is telling me that that's 19 over 18, so I'll leave it exact like that. Example 10. In a block building video game, a cube of side length x pixels is randomly generated. X is a continuous random variable with probability density function given here. So when the side length is between 20 and 40 pixels, the probability is 1 over 800 times by x plus 10. No other side length pixels appear. And we'll start with part A. And in part A, we need to find the mean of x. So that's going to be multiplying this function here by x. So I'm going to take this constant 1 over 800 to the other side of the integral sign. My limits are going to be 20 and 40, and then I multiply this by x here, and I'll get x squared plus 10x. Then what we'll do, we'll integrate it. It's easy enough to integrate. So x squared becomes x cubed over 3, and 10x integrated will become 10x squared over 2, so 5x squared. And our limits are 20 and 40. So let's substitute those in to see what we get. So that'll be 1 over 800 times by 40 cubed over 3 plus 5 times 40 squared minus 20 cubed over 3 minus 5 times 20 squared. Okay, let's see what that gives us. Right, now once I put the correct sign in here, that should have been a plus sign. And not sure why I put a minus. That should be 185 over 6. Right, let's move on to the next bit here, where we need to work out e of x squared. Right, so very similar to what I did before. Take the 1 over 800 out, and then it's just this function here times by x squared, which will be x cubed plus 10x squared, not 10 squared, 10x squared. Right, so we should be able to integrate that, 1 over 800, and then we'll have x to the power 4 over 4 plus 10x cubed over 3, and my limits are 20 and 40. So now what we'll do is we'll do our substitution. So that will be 40 to the power 4 over 4 plus 10 over 3 times 40 cubed, and then we'll subtract 20 to the power 4 over 4 plus 10 over 3 times by 20 cubed. And I've got the right sign here this time, so let's work out what that gives us. And we get 2,950 over 3. Then the third part of this question is to work out var x. Now that's easy because var x is e of x squared, which we've worked out, minus the mean squared, and we've worked out the mean as well. So all we need to do is just substitute them in. So that will be 2,950 over 3 minus 185 over 6 all squared. Right, let's see what that gives us. And we get exactly 1,175 over 36. So just highlight that. So moving on to part B, we're asked to find the expected volume. Now it's tempting on this part to say, right, well, let's take the expected length and cube it to get the expected volume, but that would be incorrect. This is the expected length cubed. Think about how you would say this and how you would write it. Expected volume, and how do we find the volume? X cubed. So if we had a question that said what's the expected area, we would go about it by saying the expected area, rather than taking the length and squaring the expected area. That gives me the area. So for this, we want E of x cubed. So that's going to be another integration, but where we multiply this by x cubed. So expected volume, E of x cubed, and that will be equal to 1 over 800 between 20 and 40, and this we need to multiply by x cubed, so we'll have x to the power 4 plus 10x cubed. Then we'll integrate that and see what we get. So for the first bit here, we'll have x to the power 5 over 5, or 1/5 x to the power 5, and then this will become 10x to the power 4 over 4, or 10 over 4 x to the power 4, and our limits are 20 and 40. Now I'm probably not going to have enough space to do my working down here, so I'm going to do it up here. Okay, so to save time, I've just written out what the working would be once we do the substitution. You can check that for yourself that this is correct, and then work that out on your calculator, and we get 32,300. So no units are given. I suppose it would be cubic pixels, but the thing is, it's a 2D image on a screen, so we'll just leave it like that, 32,300. So you should now be able to do exercise 3C on pages 59 to 62 of the textbook. There's some recap stuff here, and also information about a piecewise function with my made up notation. Hopefully that makes sense to you.